In this video, we'll talk about how to implement a class. I'll show you that by walking you through an implementation of a very bare bones point class, a class that has whose name is point, has an x and a y for its two coordinate. We'll keep track of the number of times the point moves. That's what this variable is going to do. And then it'll have what's called a constructor and a move by method. So this UML class diagram describes what the point class will be able to do. Now we're going to actually implement it. To do that, we'll go through 6 steps. First, I'll show you how to define a class, then how to do what's called the constructor, then how you get these instance variables in, the role of this thing called self, how you get methods to go, and then returning to self. So let's start with defining a class. Here, first of all, is our usual main. It's going to call test point. Test point is going to test the point class. So we're going to write a class here, and test points where we'll write our testing code. So to define a class, that's step 1. It's very simple. All you do is you write the word class, not def, but class, the name of the class, point in this case, parenthesis, and then the word object with a little o. I'll talk more about what object is in our next session, and I'll talk about what you can put there besides just object. That has to do with what's called inheritance, things that a point can extend. But for now, let's just ignore that. Again, we'll hit that on our next session. So that's all there is to defining a class. You have to have something in there, so I'll put the word pass, that just means do nothing, as a placeholder while we continue on to the next things. So again, what I've shown you is how to define a class. It's the word class, the name of the class, parentheses, and the word object at this point, lowercase o in parentheses, colon, and then whatever you're going to put below that, which we're about to talk about. So again, to define a class, you put class, point, paren object. Now let's talk about what's called the constructor of a class. It's the underscore, underscore, init, underscore, underscore method. Note that there are 2 underscores at each end. A common mistake in the exercises that you'll do following this is to leave out one of those underscores, in which case Python is confused. So let's go at this by writing in our test code that you're very familiar with. We're going to construct a point at 31.8, and we're going to call that point P1. What happens when that line of code runs is that the underscore, underscore, init method that I've just written here, shown you here, runs. In this first pass at it, it's just going to print hello. It's silly, but that's what it's going to do just to get started. So when this line, P1 gets point 31,8 runs, this special function, underscore, underscore, init, underscore, underscore runs. It's always called that. And in this example, it's going to print hello, like that. Oh. So that's all there is to the constructor, the underscore, underscore, init, underscore, underscore method. We'll talk about self in just a sec, but you just write just like it says there, and you put any code you want to run when a point in this example is constructed. The next example is going to show, the next page is going to show what we do with that 31 and that 8. So let's turn to that. Again, define a class by writing class, in this case point, paren object, define the constructor, and this time we're going to talk about defining what instance variables or data attributes, that x, y, and moves. So let's go back to our test case. We're constructing a point at 31.8, putting it in a variable P1. As we just said, when this expression, point of 31.8, runs, then this underscore, underscore, init, underscore, underscore function runs. It has self as its first parameter. We're going to talk about that shortly. And I'm now extending it to have an x and a y argument for that 31 and that 8. So the 31 goes in for x, and the 8 goes in for y in the usual way. So when this point is constructed, now we've got x here and y here, and we can store them in self.x and self.y. So self.x, meaning this point's x, will be 31. And self.y, meaning this point's y, will be 8. In this example, it's P1's x and y. So in this example, self is P1. I'll say more about self shortly, but let's plow forward. So if we were to print P1.x, see, that's the instance variable or data attribute, just like you've been using it all along. Once you say self.x equals something, then the point class has got an x attribute. Self.blah equals something, the point class would have a blah attribute, and you can put the dot there. So when you print P1x and P1y, we would have 31 and 8 show up, as shown here. You're not restricted to x and y. You could have other instance variables, other data attributes like moves. I would have called it number of moves, but I'm trying to keep the slides short. So self moves, that's the number of times the point's going to move, initially is 0. So it's perfectly okay and normal to have variables here, instance variables here, that aren't mentioned here. You usually store these, you don't have to, but you usually do, because that's data being sent in. But there can be additional data associated with the point. So if we were to print P1 moves, it would print 0 for the number of moves so far. So we've just seen how you can define instance variables. Again, all you do is inside the init function, you write self dot, the name of the variable that you want to have as a instance variable for your class. You set it to whatever it is you want to set it. And then once you construct one of these things, P1 in our example, you can say P1 dot, and whatever you put after the dot, after the word self dot down here, is an option for P1 dot there, because in this example, P1 is self. Again, more on self shortly. All right, so now let's talk about our last point, methods. Again, to review, to define a class, you say class point objects. I'm writing my class over here and my testing code over here in this slide. To define this constructor means to define the underscore init. If we have a point at 31.8, that means that we're going to set our x and y instance variables or data attributes, two words for the same thing, to 31 and 8 respectively in this example. And we're going to initialize the number of moves, number of times this point is moved, to 0. If we then print the three numbers, we get 31 and 8 and 0 for the number of moves. Now, again, now we're going to introduce methods. Suppose what you wanted to do is take point 1 and move it by 10 in the x direction and by -5 in the y direction. In other words, you wanted to go from 31 to 41 for x and from 8 to 3, subtracting 5, for y. Well, what you do is over there in the class, you define a move by method just like the underscore init. So here it is coming along. There's def move by. It has self just like init has. And because there are two arguments here, there are two arguments here. The change in x, which I've called dx, and the change in y, which I've called dy. Pause for a moment and think about what lines of code you would write there to change this point's x by dx and this point's y by dy. What statement would you write there? I hope you see that you would take this point's x, that's self dot x, becomes what it was, 31 in our example, plus dx, 10 in our example. Self's y is self's y plus 31. So if we, and self's moves would also have to go up by 1. So if we were to print those variables, we would find that we have originally 3180, but now 413, and we've now made one move, so it's gone up by 1. Let's see, and if we were to, the role of self. So self stands for the object that you're dealing with. So in this case, when you construct a point and call it P1, when you say P1 dot, P1 is self. Self is P1. To emphasize that, let me show you another way you could write things. You could write this statement up here, P1 dot move by 10 minus 5, as go to the point class, run the move by method, and put in P1 for self. Put in 2 for dx and 5 for dy in this example. And it would move P1 by 2 and 5 respectively. So if you printed out your things there, you would find that it went up 2 from 41 to 43 and from 3 to 8 up 5 there, and that you've made a move. So this emphasizes that even though we use the dot notation, we always write it this way and never this way. All the P1 dot means is that P1 is going to be used as self in the class that you're writing the code for. And if you want to refer to that variable in front of the dot as you're writing the code, it's self dot. So this points, the one that you're working with, its x goes up by dx, and so forth. I guess I have one last thing to say, and that's via this number, this line. If you want to refer to another method inside the code, again you say self dot. So if for some silly reason I wanted to call move by from within init, you never would. But if you did, you would say self dot and then the other method you want to call. So as you write code in your exercises, you're going to find that you're going to want to call methods you've already made from methods you're in the process of making. Self dot method name is the notation. Well, good luck. Ask questions, and we'll see how it goes when you do those exercises.